Welcome back to the workshop for one last video on functions. We took a look in the last video on function composition. So in this video, we want to take it one step further and recognize when we're talking about function composition. Within function composition, talking about inverses. All right, so inverses. Suppose that f is a function from a to b, and it is a one-to-one correspondence. Then the function f inverse of x, need a little bit more room, f inverse of x, which is a function from b to a, defined by f inverse equals, remember that this is a relation, so f inverse, right, this is a relation, f inverse is a notation for the relation, and it's defined by a collection of ordered pairs. So y comma x is in the inverse whenever we have that x comma y belongs to the original function. All right. Again, this is the inverse function of f. And what we're doing here is if we have our set A and our set B, let's see here, take a couple of elements. Let's go with x and y. If we have our function f, which takes f to y, okay, x comma y is in the function f, then what happens is the function f inverse takes y and sends it over to f. Easy enough. This is the inverse. When you compose inverse functions, right, if I were to do f first, I would take x to y, and then I would do f inverse and take y back to x. So we're going to get x. It doesn't change. It just brings us back to where we started. So that is the identity function. When I compose two functions that are inverses, I should do something to x and then undo it, giving me back what I started with. That's the identity function. The composition should be the identity. Similarly, if I were to start with the inverse does something, and then the original function undoes the inverse. So I should, again, if I start with y, f inverse does something to it, f undoes that, and I get back y. So again, compose them, and I should get the identity function. And that's exactly what we saw here, right? The two functions undid one another. So these two are actually inverse functions. All right, so let's take a look at an example where we want to compute. We want to find the inverse. And what we're going to rely on is we're going to rely on this relationship here, this definition of the inverse. So the computation of an inverse, the finding of an inverse, is no different here than what you may have done in the past. So the only difference is that we should start by saying, hey, this is one-to-one and onto. So first, note that the function, note that, let's see, that the function f is a one-to-one correspondence. We need that in order for it to have an inverse. That's what our definition said up here. Suppose f is a one-to-one correspondence. All right, so yes, it is a one-to-one correspondence, so we can find the inverse. All right, so find the inverse. And it's done in the same way that you may have done it in the past, where we exchange x and y and then solve for y. Of course, there's no y in this case, so the first thing we do is we replace f of x with y. And when we do that, we get y is equal to the cube root of x plus 1. Now, the only reason that we did that is so that way we can recognize that we have an x and a y. That's it. That's the only reason we did it. Now the next step is to actually find the inverse relation. So how do we do that? Well, all we do is swap x and y. If x comma y is in f, then exchanging them gives us the inverse. So swap x and y, and we get x is equal to the cube root of y plus 1. And here, it's very important to note, this is the inverse. We've already found the inverse, but what we need to do is we need to take it a step further and write it in function notation. So we found the inverse, we just need to write it in function notation. How do we do that? Well, we solve for y and then use f inverse of x. So solve for y. Now this might take a little bit of algebra, and I would encourage you to show that algebra. In this case, I will tell you that what you should find through the use of algebra, through the use of actually solving for y, what would you have to do? Well, I'd have to do this, and I have to do that. Show those steps. Show it. Okay. Y is equal to x cubed minus 1. Show your work. Exclamations points, because that's an expectation of you. When you submit your homework, when you submit an exam, you need to show your work. You can't simply say, this is the answer. You might be right. You might be right, that is the answer. But what you've not done is said, I know what I'm doing. You've simply said, I know how to find the answer somewhere. You haven't actually said that you know how to get the answer through your own work. The only way you can show that is by showing your own work. So please make sure that you're doing that. All right, solve for y, and then finally replace y with f inverse of x. So f inverse of x is equal to x cubed minus 1. And if you wanted to check your answer, if you wanted to confirm that this is in fact the inverse, you could compose the two functions both ways, and in each case you should get x, right? You should get the identity function. All right, and that is the end of section 2.4 on functions. Thank you for your time and attention. I'll see you guys back in the workshop for section 2.5 a little bit later. Have a great day.